pyramids of Giza were so prominent that history never forgot who built them.
The pyramids of Egypt have towered over the desert sands for millennia, their true purpose shrouded in mystery despite centuries of research.
Scientists spent 2 years using new technology to see through the pyramid. It's still unclear what's inside the chamber.
While mainstream archaeology has long held that these massive structures served as elaborate tombs for the pharaohs, recent discoveries are challenging this narrative in surprising ways.
And all of this is like very, very, very weird.
From hidden corridors detected through cosmic rays to revolutionary findings about their geographical placement, scientists are piecing together a more complex picture of these ancient wonders. Could the Great Pyramid of Giza have served a function far beyond housing the dead? The answer might reshape our understanding of ancient Egyptian civilization entirely.
The pyramids from the Old Kingdom became for everyone.
The silhouette of the pyramids against the Egyptian sky represents one of humanity's most enduring mysteries. These colossal structures have captivated explorers, scientists, and dreamers for thousands of years, their sheer scale defying explanation even with modern technology. The Great Pyramid of Giza, built for Pharaoh Khufu around 2560 BCE, stands as the largest of these monuments, originally reaching 481 feet into the sky before time stripped away its smooth limestone casing. What makes these structures so enigmatic isn't just their size, but the precision with which they were built. The Great Pyramid's base is level to within just 2.1 centimeters across its entire 13-acre footprint, an astonishing feat for ancient builders without modern surveying equipment. Its sides are aligned to the cardinal directions with an accuracy of 3/60ths of a degree. These aren't just impressive achievements, they're engineering anomalies that have puzzled experts for generations. The pyramid's inner structure presents even more questions. A complex system of passages, chambers, and shafts seems deliberately designed with purpose, though that purpose has remained elusive. The king's chamber, constructed entirely of granite blocks weighing up to 80 tons each, contains nothing but an empty sarcophagus. No mummy, no treasure, no hieroglyphic inscriptions to explain its function, just an empty box made of stone. Adding to the mystery, the Great Pyramid contains enough stone to build a wall around France that's 10 feet tall and 1 foot thick. Approximately 2.3 million blocks, each weighing between 2.5 and 15 tons, were somehow transported, lifted, and precisely placed to create this monument. The logistics alone suggest an extraordinary investment of resources and labor for ancient Egyptian society. Further complicating our understanding, the construction techniques remain contested. How did workers transport these massive stones from quarries? How did they lift them hundreds of feet into the air? How did they achieve such precision without modern tools? The conventional explanations, ramps, rollers, and brute force seem inadequate when scrutinized closely. Even the timeline raises questions. Most Egyptologists believe the Great Pyramid was built over a 20-year period. This would require placing approximately 800 tons of stone every day, one massive block every 2 minutes of daylight. Such a pace seems nearly impossible for ancient technology, leading some researchers to question either the timeline or our understanding of Egyptian capabilities. The conventional wisdom about the pyramids, that they served primarily as tombs for Egyptian rulers, isn't without substantial evidence. When we examine the historical record and archaeological findings, we find numerous indications supporting this function. The evolution of pyramid construction itself tells a compelling story. The first true pyramid, the Step Pyramid of Djoser, built around 2630 BCE, developed from earlier burial structures called mastabas. These flat-roofed rectangular tombs eventually stacked on top of each other, creating the step-like appearance that would influence later pyramid design. This clear progression from simpler burial chambers to more elaborate structures suggests a continuation of funerary purpose rather than a radical shift in function. Textual evidence also supports the tomb theory. The pyramid texts, the oldest known religious writings in the world, were inscribed on the walls of pyramids beginning with the Pyramid of Unas around 2375 BCE. These texts explicitly describe the afterlife journey of the pharaoh, including spells and instructions for reaching the realm of the gods. Their presence inside the pyramids strongly suggests these structures were designed with the deceased ruler's spiritual journey in mind. The physical context of the pyramids further reinforces their funerary role. Each major pyramid complex included several components beyond the main structure: a mortuary temple where priests would make offerings to the deceased pharaoh, a causeway connecting to a valley temple near the Nile, and often smaller pyramids for queens and other royal family members. This entire complex mirrors known Egyptian burial practices just on a grander scale. Archaeological findings within some pyramids also point to their use as tombs. While the Great Pyramid of Khufu notably contained no body when first explored in modern times, other pyramids have revealed more direct evidence. The Pyramid of Pepi I, for instance, contained mummy wrappings, canopic jars for storing organs, and other funeral items. The absence of remains in many pyramids can be attributed to extensive looting throughout history, which is well documented in ancient Egyptian records. The location of the pyramids on the west bank of the Nile is another significant clue. In Egyptian cosmology, the west, where the sun sets, was associated with death and the afterlife. This placement wasn't arbitrary but deliberately aligned with religious beliefs about the journey to the afterlife. Even the internal structure of the Great Pyramid aligns with funerary purposes. The burial chamber contains a sarcophagus sized appropriately for a human body, and the narrow shafts pointing toward specific stars may have been intended as pathways for the pharaoh's spirit to travel to the celestial realm. These architectural features make little sense for any purpose other than facilitating the deceased ruler's journey to the afterlife. The resources dedicated to pyramid construction also fit with what we know about Egyptian attitudes toward death. Ancient Egyptians believed preparation for the afterlife was the most important aspect of existence. The pharaoh, as both political leader and divine intermediary, would naturally require the most elaborate preparations for this journey. The immense resources devoted to pyramid construction reflect this priority rather than suggesting some alternative technological function. In March 2023, scientists made a breakthrough discovery that sent ripples through the archaeological community. Using advanced muon radiography, a technique that detects cosmic particles passing through solid objects, researchers identified a previously unknown corridor within the Great Pyramid of Giza. This passageway, measuring approximately 30 feet long and situated near the main entrance on the north face, had remained hidden for over 4,500 years. The discovery wasn't accidental. It came as part of the Scan Pyramids project, an international research initiative using non-invasive technologies to map the internal structures of Egypt's ancient monuments. The team had previously detected this void in 2016, but it took years of additional research to confirm its existence and determine its dimensions. What makes this find particularly significant is that it represents the first major structural discovery within the Great Pyramid since the 19th century. This hidden corridor raises compelling questions about the pyramid's design and purpose. Positioned directly above the pyramid's main entrance, it appears strategically placed. Some researchers suggest it might have been designed to redistribute weight and prevent the ceiling of the main entrance passage from collapsing, a remarkable feat of ancient engineering if true. Others speculate it might lead to additional undiscovered chambers deeper within the structure. Dr. Mostafa Waziri, head of Egypt's Supreme Council of Antiquities, described the corridor as horizontal and noted it appears to have been built to relieve stress on the pyramid's structure. This is a very important discovery, he stated in the research published in Nature Journal. The technology used to make this discovery is equally impressive. Cosmic ray muon radiography works similar to X-rays but can penetrate much denser materials, allowing researchers to see through hundreds of feet of stone without damaging the ancient structure. But this isn't the only recent discovery challenging our understanding of the pyramids. Just a year later, in May 2024, another team of researchers using ground-penetrating radar, GPR, and electrical resistivity tomography, ERT, detected what they described as an L-shaped anomaly in the Western Cemetery near the Great Pyramid. This unusual formation, along with an accompanying structure, hints at a possible entrance to deeper, previously unknown chambers. These discoveries come as part of a broader technological revolution in archaeology. Non-invasive techniques now allows scientists to explore these monuments without physically entering them, preserving their integrity while revealing their secrets. Modern tools like GPR thermal imaging, 3D scanning, and cosmic ray muon detection are providing unprecedented insights into structures that have stood for millennia. The significance of these hidden spaces extends beyond mere architectural curiosity. If the pyramids were designed solely as tombs, why include elaborate hidden corridors and chambers that would never be seen? Some researchers suggest these spaces might have had ceremonial importance, perhaps used during construction for rituals we don't fully understand. Others propose they might have served practical purposes related to the structure's stability or even its acoustic properties. Particularly intriguing are the air shafts in the king's and queen's chambers that extend toward the exterior of the pyramid. Initially thought to be ventilation channels, their careful alignment with specific stars has led some researchers to suggest they had astronomical significance instead. In 2002, a robot explorer sent up one of these shafts discovered a small door with copper handles, behind which another chamber may exist. These ongoing explorations continue to reveal the pyramid's complexity. One of the most significant recent breakthroughs in pyramid research came not from examining the structures themselves, but from studying the landscape around them. In early 2024, scientists published findings that may finally explain one of the most persistent mysteries about pyramid construction: how ancient Egyptians transported massive stone blocks to build these monuments. Using a combination of radar satellite imagery and sediment core analysis, researchers discovered evidence of a now dried-up branch of the Nile River that once flowed much closer to the Giza Plateau than the river does today. This ancient waterway would have brought the river almost directly to the foot of the pyramid construction sites, dramatically changing our understanding of how these monuments were built. We've found the former channel of the Nile, which was much closer to the pyramids than it is today, explained Dr. Emin Gonim, one of the lead researchers on the study. This explains how they transported construction materials to the site. Core samples taken from the area revealed sediments typically found in river bottoms, confirming that water once flowed through what is now dry desert. This discovery solves a logistical problem that has puzzled experts for generations. The massive granite blocks used in parts of the Great Pyramid came from quarries in Aswan, nearly 600 miles away. The limestone that forms most of the structure was quarried closer, but still required transport across significant distances. Traditional theories involving sledges dragged across the desert seemed inadequate for moving millions of multi-ton blocks efficiently. With access to a nearby waterway, however, ancient builders could have used boats to transport these massive stones much more efficiently. Egyptian artwork from the period shows large stones being moved on barges, supporting this theory. Water transport would have reduced the labor required by orders of magnitude, making the construction timeline more plausible. But the implications of this discovery extend beyond mere logistics. The careful positioning of Egyptian pyramids has long been noted for its precision and apparent deliberateness. Finding that they were specifically built along what was then a major waterway suggests their placement may have been even more strategic than previously thought. The location along this former Nile branch would have made the pyramids more visible to those traveling the river, Egypt's main highway in ancient times. This supports theories that the pyramids served not just as tombs but as powerful symbols of royal authority and divine connection, meant to be seen and inspire awe in the population. Moreover, water held deep religious significance in ancient Egyptian culture. The Nile was considered the source of all life, and its annual flooding cycle shaped Egyptian understanding of death and rebirth. Building these massive monuments to the afterlife alongside the river would have connected them symbolically to this cycle of regeneration. This geographical revelation also helps explain another curiosity: why pyramid construction eventually ceased. As the Nile's course naturally shifted over centuries, the logistical advantage of waterside construction diminished. This change in the landscape might have contributed to Egypt's transition to rock-cut tombs in the Valley of the Kings during later dynasties. While traditional archaeology has focused on the pyramids' role as tombs, a fascinating alternative theory has gained attention in recent years, one that suggests the Great Pyramid might have served as a sophisticated device capable of emitting light or energy. This hypothesis, though controversial, draws on several unusual features of the pyramid that have long perplexed researchers. At the center of this theory is the remarkable electrical conductivity of the limestone used to construct the Great Pyramid. Studies have shown that the nummulitic limestone that forms much of the structure contains properties that make it unusually conductive, particularly at frequencies around 600 terahertz. This characteristic differs significantly from ordinary limestone and has led some researchers to question whether this material was deliberately selected for its electrical properties rather than simply for convenience or aesthetics. The internal chamber system of the Great Pyramid also features prominently in this hypothesis. The subterranean chamber carved deep into the bedrock beneath the pyramid contains unusual features that don't align well with burial practices. Some proponents of the light emission theory suggest this chamber might have functioned as part of a hydrogen production system. According to this view, the chemical reactions between limestone, water possibly from an underground aquifer, and other elements could have generated hydrogen gas. Moving upward through the pyramid, the Grand Gallery, with its distinctive corbel design, features prominently in this hypothesis. Its unusual architecture with precisely angled walls rising to a height of 28 feet doesn't match typical Egyptian construction patterns for tombs. Advocates of the light emission theory suggest it might have served as a focused pathway for energy generated within the structure. The king's chamber, traditionally viewed as the burial place for Pharaoh Khufu, contains another curiosity. It's constructed entirely from granite. Unlike most of the pyramid, granite contains high concentrations of quartz crystal and is known to exhibit piezoelectric properties, the ability to generate an electrical charge in response to mechanical pressure. The massive weight of the pyramid pressing down on this chamber could theoretically create electrical effects within the granite. Perhaps most intriguing are the narrow shafts that extend from the king's and queen's chambers toward the exterior of the pyramid. Conventional archaeology suggests these might have served as pathways for the pharaoh's spirit, but their precise alignment to specific stars has led to alternative interpretations. According to the light emission theory, these shafts might have channeled electromagnetic energy between the interior chambers and the outside world. The pyramid's location at what some researchers identify as the geographical center of Earth's landmass adds another layer to this hypothesis. This positioning would be remarkably advantageous for a structure designed to interact with the planet's electromagnetic field. The theory suggests that free electrons generated within the pyramid could have been emitted upward, reaching the ionosphere approximately 100 kilometers above Earth's surface. In this scenario, the interaction between these emitted electrons and the ionosphere could create a phenomenon similar to the aurora borealis, essentially a controlled light display. The electrons would then complete their circuit by returning to Earth via elevated points and the mantle, with the pyramid's location at Earth's geographical center facilitating this process. Proponents of this theory point to accounts from ancient Arab historians who describe the Great Pyramid as occasionally emitting light visible from great distances. While these accounts are difficult to verify, they add an intriguing historical dimension to the hypothesis. Modern experiments with scale models have produced some interesting results. Small pyramid structures built with similar proportions to the Great Pyramid have been shown to concentrate electromagnetic energy in their internal chambers. While these experiments don't prove the ancient structure was designed for this purpose, they demonstrate that its geometry does create measurable electromagnetic effects. Critics of the light emission theory argue that it lacks archaeological evidence and relies too heavily on modern concepts being applied to ancient structures. They point out that no electrical components have been found within the pyramid, and that contemporaneous Egyptian texts make no mention of such technology. The stones that form the Great Pyramid aren't just architectural elements, they're scientific clues that might help reveal the structure's true purpose. Recent laboratory analyses of these materials have yielded surprising results that add weight to both traditional and alternative theories about the pyramid's function. The primary building material of the Great Pyramid is limestone, but not just any limestone. Researchers have identified it specifically as nummulitic limestone, named for the tiny fossil shells it contains. These nummulitic fossils, remnants of ancient sea creatures, give the stone unique properties not found in ordinary limestone. Laboratory tests have shown that this specific type of limestone exhibits unusual electrical characteristics with particularly high conductivity at certain frequencies. Dr. Joseph Davidovitz, a materials scientist, has proposed that some of the stones might not be quarried natural limestone, but rather a form of ancient geopolymer, essentially an early form of concrete.
We have replicated all these surfaces just by varying the amount of water, which depends on the climate, it depends on the weather.
According to his analysis, certain blocks show chemical signatures consistent with reconstituted limestone rather than cut stone. This theory remains controversial, but if true, it would suggest the ancient Egyptians possessed advanced knowledge of chemistry and materials science. The granite used in specific areas of the pyramid, particularly the King's Chamber and parts of the Grand Gallery, has also attracted scientific interest. This granite, quarried from Aswan hundreds of miles away, contains high concentrations of quartz crystal. Under pressure, quartz exhibits piezoelectric properties. It generates a small electrical charge. The immense weight of the pyramid's upper portions pressing down on these granite structures could theoretically create electrical effects, though measuring such phenomena in the ancient structure presents significant challenges. Equally intriguing are studies of the pyramid's former outer casing. Historical accounts describe the Great Pyramid as once covered in highly polished white limestone that made it shine brilliantly in the sunlight. The few remaining casing stones confirm this description. They're made of fine white limestone with a reflectivity approaching that of a mirror. Recent analysis shows these casing stones contain a high concentration of calcite crystal, giving them unusual optical and electromagnetic properties. Thermal imaging studies conducted on the pyramids have revealed another curious property. They appear to maintain a more consistent internal temperature than would be expected from passive stone structures. Some researchers suggest this might indicate sophisticated ventilation or insulation properties built into the design, though others attribute it simply to the massive thermal mass of the structures. Chemical analysis of mortar samples from between the pyramid blocks has identified unusual compounds not typically found in ancient construction. These include complex calcium compounds that exhibit remarkable durability, having maintained their binding properties for over 4,500 years. Perhaps most remarkably, researchers have detected traces of metals like iron and nickel in some stone samples from deep within the pyramid, elements not typically found in limestone. While some suggest that these might be evidence of advanced metallurgical knowledge, others propose more mundane explanations, such as contamination from modern exploration equipment. One of the most compelling aspects of the Great Pyramid's placement involves its relationship to Earth's geography. Located at 29.9792 degrees north latitude, the pyramid occupies a position that some researchers identify as the center of Earth's landmass. If all the continents were weighted equally, their center of gravity would fall remarkably close to the pyramid's location. This geographical centrality might seem coincidental, but it becomes harder to dismiss when considered alongside other precision aspects of the pyramid's construction. For ancient builders working without satellites or global mapping technology, determining Earth's landmass center would seem impossible. Yet somehow the pyramid stands within a fraction of a degree of this significant geographical point. The implications of this positioning extend beyond mere curiosity. From a practical standpoint, placing a structure at Earth's landmass center would maximize its interface with the planet's electromagnetic field. If the pyramid did serve some function related to energy or electromagnetic phenomena, as some alternative theories suggest, this central location would be extraordinarily advantageous. Adding to this geographical significance, the Great Pyramid sits precisely on the 30th parallel north, a latitude line that passes through several ancient sites worldwide. This alignment suggests a potential ancient understanding of global coordinates that challenges conventional views about early civilizations' geographical knowledge. The pyramid also occupies a special position relative to the Nile Delta. It sits at the exact point where the Nile Valley meets the Delta region, effectively marking the boundary between Upper and Lower Egypt. In ancient Egyptian cosmology, this position held profound symbolic importance as the meeting point of the two lands under the pharaoh's rule. Beyond earthbound geography, the pyramid's placement shows remarkable astronomical alignments. Its four sides align with the cardinal directions with an accuracy of 3/60ths of a degree, a precision difficult to achieve even with modern surveying equipment. This alignment allows the pyramid to mark the equinoxes precisely, as the sun casts no shadow on its north side at noon during these astronomical events. Some researchers suggest this precise positioning relative to both terrestrial and celestial reference points indicates the pyramid was intended as a type of geodetic marker, a reference point for measuring Earth. The pyramid's dimensions encode various mathematical relationships that appear to reference Earth's size and shape, including approximations of pi and the golden ratio. Beyond its remarkable geographical positioning, the Great Pyramid exhibits astronomical alignments so precise they continue to astound modern astronomers. These celestial connections suggest the structure was designed with a sophisticated understanding of the heavens that goes far beyond what most historians attribute to ancient Egyptian civilization. The most obvious astronomical feature is the pyramid's orientation to the cardinal directions. Its four sides align almost perfectly with true north, south, east, and west, with an error margin of just 3/60ths of a degree. For comparison, even the Greenwich Observatory in London, built in 1675 with far more advanced technology, was initially misaligned by 9/60ths of a degree. How ancient Egyptians achieved this precision without modern instruments remains a subject of intense debate. Even more remarkable are the pyramid's internal shafts and their stellar alignments. The northern shaft from the King's Chamber points directly toward the circumpolar stars, specifically targeting the position where Alpha Draconis Thuban would have been around 2500 BCE. This star held the position of pole star during the pyramid's construction era. Meanwhile, the southern shaft from the same chamber aligns with the stars in Orion's belt, specifically with Alnitak, the easternmost star in the belt. The Queen's Chamber shafts show equally deliberate alignments. The northern shaft points toward the circumpolar stars, while the southern shaft aligns with Sirius, the brightest star in the night sky, and one associated in Egyptian mythology with the goddess Isis. These alignments aren't random, they connect specifically with stars that held profound religious significance in ancient Egyptian cosmology. The precision extends beyond stellar alignments to incorporate solar phenomena as well. During the equinoxes, the pyramid casts no shadow at noon, an effect that would have been visually dramatic when the structure was covered in its original highly polished white limestone casing. On the summer solstice viewed from the Sphinx, the sun sets precisely between the Great Pyramid and its neighbor, the Pyramid of Khafre, creating a dramatic visual effect that marks the year's longest day. Mathematical relationships encoded in the pyramid's dimensions suggest an advanced understanding of astronomical cycles. The perimeter of the pyramid's base, when divided by twice its height, gives a close approximation of pi 3.14159. Similarly, the pyramid's dimensions appear to reference the length of the solar year, the precession of the equinoxes, and other astronomical constants with remarkable accuracy. Particularly intriguing is the correlation between the Giza Pyramid complex and the stars of Orion's belt. When viewed from above, the layout of the three main pyramids mirrors the pattern of these stars, not just in arrangement, but in relative size and offset alignment. This pattern extends to the relationship between the Nile River and the Milky Way galaxy. The pyramids sit west of the Nile, just as Orion's belt appears west of the Milky Way in the night sky. Some researchers go further, suggesting the entire Giza Plateau represents a deliberate star map of the important Duat region of the Egyptian night sky. This theory proposes that various structures across the plateau correspond to specific stars and constellations, creating a terrestrial reflection of the celestial realm central to Egyptian afterlife beliefs. With such diverse and sometimes contradictory evidence, how might we reconcile the traditional tomb theory with these newer findings suggesting additional purposes? Perhaps the most compelling approach is to recognize that the pyramids likely served multiple functions simultaneously, each layer of purpose reinforcing the others in a complex symbolic and practical system. At its foundation, the evidence for the tomb function remains strong. The sarcophagus in the King's Chamber, the associated mortuary complexes, and the historical context all point to a funerary role. But this doesn't preclude the pyramids from serving additional purposes that enhanced their primary function. The astronomical alignments, for instance, make perfect sense within the context of Egyptian afterlife beliefs. If the pharaoh's soul was intended to ascend to the celestial realm after death, aligning his tomb with significant stars would create a symbolic pathway for this journey. The shafts pointing towards specific stars might have served as spiritual conduits rather than literal pathways, guiding the king's spirit to its rightful place among the eternal stars. Similarly, the pyramid's geographical positioning at Earth's landmass center could have held powerful symbolic significance. In Egyptian cosmology, their land was considered the center of the world, the meeting point between heaven and earth. Placing the pharaoh's tomb at this central point would emphasize his role as mediator between realms and reinforce his divine status. The electromagnetic properties observed in the pyramid materials might have had religious rather than technological significance. Ancient Egyptians were keenly aware of natural phenomena like static electricity, which they may have interpreted as manifestations of divine power. Creating a structure that concentrated or enhanced these effects could have been seen as capturing divine energy to assist the pharaoh's transformation into a god. Recent discoveries about the nearby Nile branch explain the practical aspects of construction while adding symbolic depth. Water was central to Egyptian concepts of rebirth and renewal. Building the pharaoh's eternal home alongside the life-giving Nile would connect it symbolically to the cycle of regeneration, reinforcing its role in facilitating his rebirth into the afterlife. The hidden corridors and chambers revealed by modern scanning technology might have had both practical and ceremonial purposes. Some might have served to distribute structural weight, while others could have housed ritual objects or provided spaces for ceremonies we no longer understand. Their hidden nature aligns with Egyptian beliefs about the afterlife journey, filled with secret passages and chambers the deceased would navigate. Perhaps most significantly, these various functions would have reinforced each other rather than competing. A structure that demonstrated astronomical knowledge, incorporated sophisticated engineering, manipulated electromagnetic phenomena, and stood at Earth's central point would powerfully symbolize the pharaoh's divine authority and knowledge, making it the perfect vessel for his journey to godhood after death. This integrated view suggests the pyramids weren't just tombs but cosmic machines designed to transform the pharaoh into a god, combining religious symbolism with practical engineering and natural phenomena in a way that reflected the holistic worldview of ancient Egyptian civilization.